cosine tan 2x. Have you seen chain rule before, or like, give me kind of your understanding of it, because I can jump right into how to do it, or I can break it apart into pieces based on what you tell me.
We've been going over it in class.
Okay, so the shortcut here is to recognize, like, what is the outside function? The outside function is sine. So the derivative of sine is cosine, and you keep the inside function. So the next most inside function is tangent. The derivative of tangent is secant squared, and you keeping the inside function until you get to the innermost function. So the derivative of 2x is 2. And this is considered complete. Did you follow that? Is that clear? If it's not, I can go through it again.
Go through it again one more time.
Okay, so that's where I'm going to do this slightly differently. I'm going to say y equals sine u, and u over here is tangent of 2x. So y prime is the derivative of sine. The derivative of sine is cosine u times u prime. Now, what is u prime? Well, u prime is the derivative of this thing over here on the right. But this is really tangent of v, and v equals 2x. And I'm doing it this way because you want to only take derivatives of stuff you know. The derivative of u is the derivative of tangent, that's secant squared v times v prime. And now you need v prime. V prime is derivative of 2x, which is 2.
Okay.
So now you piece it all together. Okay. Like you start back substituting. Well, what's v prime? Well, it's 2. What's v? It's 2x. So u prime is really secant squared of 2x times 2. What's u? Well, u is really 2 tangent of 2x. U prime is this stuff here. So y prime equals cosine of the tangent of 2x times u prime. U prime is all this stuff over here, secant squared 2x times 2. So notice it's exactly the same as this top line that I wrote. There's just more that went into it to sort of like piece it together. And that's where there's these two approaches. It depends on like whether you can identify the outer and the inner functions as you go.
That's my main problem right now.
Okay.
Identify. Okay, so for the first one, the first row that you wrote, just the regular y prime equals all that.
Yes.
So what you did is cosine is the outside.
Yes.
Right, and then tangent 2x is the inside, obviously.
That's right.
So you take the derivative of the outside, write the inside function, and then next you kind of treat the tangent 2x like tangent being the outside function.
Exactly. And furthermore, you can almost like X out the sign. You're done with it.
Yeah. And then you just keep going until you.
Yes. Exactly. So if you, because at some point in this class, you have to be able to do this one line that quickly and not do the rest of the stuff to be successful in the class. Because so that's where, I mean, it's kind of blunt, but that's what it is. All right. How about 32? I'm gonna go to 32 next. Snip that in. Okay. This one is not a chain rule problem, but it includes the chain rule. So do you want me to only do chain rules or just, or kind of talk about ones that include the chain rule?
Include the chain rule.
Okay.
Rule as well.
So this is product rule. And it's product rule because it's a product of two things, but the derivatives have a chain rule element to it. So you generally start with either like a product or a quotient and then move to chain rule inside of here. So do you remember product rule?
Yes, sir, I do.
Okay, so the product rule says, I'm gonna make this a u and this a v. It says u v prime plus u prime v. So you have to be able to take the derivative of each of these, and I'll do it again here. U equals x, v equals sine 1 over x. Now the derivative of x is 1. That's pretty straightforward. This is what has a chain rule component to it.
Mhm.
So V is going to be the sine of W. So generally in math, your progressions are U, V, and W for substitutions. And then you might go to like RST if you had to really like get really deep into these things. But W is 1 over X in this case. So your V prime, the derivative of sine is cosine of W, W prime. And now you need W prime over here, and that's power rule, right? That's X to the -1.
Mhm.
So it becomes -1 X to the -2 or -1 over X squared. And then you start backfilling, these things in there because your product rule, you're just piecing it together. So we've got all these pieces over here. So U is X, V prime is cosine of W, but W is 1 over X. Okay.
Mhm.
But then there's this W prime, which is -1 over X squared, plus U prime, which is 1 times V sine 1 over X. Now, I like what you did in the last problem. Do you want to try and repeat what I said back to me to kind of confirm your understanding, or do you want me to try and explain it again
Um,
before you do that?
I'm just like going back over in my head. I'm sorry.
No problem.
Yeah.
I'm going fast. I'm sorry for that.
No, you're good.
The like if you realize, okay, it's X, like it's the derivative of the first. So a lot of students do derivative of the first. Like the order doesn't matter here. Sometimes people do it backwards, forwards, doesn't matter.
I usually do it U V prime V
U prime. Yeah, and that's what I was going to write, but textbooks write this way. So I like the way you wrote it. So U is X. Okay, there's my X. Now I got to take the derivative of sine 1 over X. And like you told me, you take the derivative of the outside function. The derivative of sine is cosine. Keep
Mhm.
the inside function. Then you say, I've already dealt with sine. What's the derivative of 1 over X? -1 over X squared.
Mhm.
That closes out the derivative of everything, to the right here. Then you say, okay, I got to keep I got to take the derivative of X, that's 1, and then keep the second.
Mhm.
If you keep doing this, you will truly be able to do this in one step here. It's just, it takes a little while
Yeah.
to be able to do that. Okay. There's many good ones here. I'm going to stick to the ones that I think like are easier to understand to start out. And we're going to move to 33 next because it's a quotient rule derivative. You got to know quotient rule. It's got chain rule components to it. This is a solid test question that you might see here. All right.
The ones with where it's a fraction are my main problems.
Is this one of those that you would include in that?
Yes.
Okay.
Trying to figure out. Okay, actually,
What is the outside function here?
I think X to the 4th, maybe.
Yeah, so you could rewrite it, and maybe we should do that. Let's write this as y equals, and I'm gonna use a different letter. I'm gonna use w to the 4th, and w is 1 minus cosine 2x over 1 plus cosine 2x. What is the derivative of this? It's 4w cubed w prime. Is that part okay?
Hang on. What are you taking the derivative? Okay. Hang on.
W is all the, like you said it. You said like x to the
Mhm.
4th. I chose w because x is already in here, and that there can be a little confusion when you map the same variable onto itself.
Where did you? Why did you do the 4W to the 3rd
That's
W
power.
prime?
That's power rule. That's power rule.
Uh-huh.
You know that one. That's the first one
Yes,
you
sir.
you learn.
Yes, sir.
Okay. And then w prime. This is the chain rule. So notice that power rule can have chain rule. Product rule can have chain rule. They all have chain rule. They don't tell you that when you start out because it would blow your mind. You'd just be like, oh my God, I don't understand. But they all have chain rule in there. So is that part okay?
Yes.
All right. Now, just as kind of like, if you eventually you're going to do this, you're going to write 1 minus cosine 2x, 1 plus cosine 2x, like this to the power of 3. And that's this first part here.
Yeah, that's how we usually start it, like that.
And you can do that. This is just like, this is how it kind of all works. So now you got to take the derivative of this. This is a quotient rule problem. Do you agree with that? Do you see
Yes,
that?
sir.
This is
Yes,
quotient
yes.
rule. So we got u over v, and that's why I didn't immediately go to u. The words I think are more helpful. W prime is bottom times derivative of the top minus the top times the derivative of the bottom over the bottom squared. It would be really good if you were able to do this and write it out as you go. So the bottom is 1 plus cosine 2x, and it is totally okay that this is messy. It's supposed to be. What is the derivative of the top? The derivative of the top is, the derivative of 1 is 0. What is the derivative of minus cosine or cosine?
That'd be sine.
It'd be sine. Its cosine is minus sine, so the minus, so makes it sine. Sine of 2x, but there's chain rule.
Yep.
So that means it's times 2. So what we just wrote down is this u prime. It's just that part. The v is this part over here.
Okay. And then the sine 2x2 is the u prime.
Yes, this is this. Let me go to color here, different color. This right here is u prime.
Okay.
And the goal is to be able to get you to do that on the fly here. So now it's u. You need to write u. U is 1 minus cosine 2x. Maybe the colors are helpful here. I don't know. This is u. Okay. Then you got to find v prime. So v prime is the derivative of the bottom. What is the derivative of 1?
It'd be 0.
0. You can write it, but they don't want you ultimately. What's the derivative of cosine?
Negative sine.
Negative sine of 2x. You keep the inside function. Then you have to take the derivative of the inside function, which is
2.
All over, this is why you don't simplify, the bottom squared. 1 plus cosine of 2x squared. Now you're done.
Yeah.
Okay, to check if you understand this, 38 is kind of a good one to do because it's really weird, but it's a repetitive like chain rule. And one of the things I would do with 38 is and you're always allowed to do this, you're always allowed to write it out again. So it's x plus, okay, because my outside thing is going to be to the 1/2 power. That's what the square root means. X plus x to the 1/2. So this x to the 1/2 is this one. This square root here with x is this 1/2 here. And then the big one is the one on the outside here. Are you okay with how that was written? All right.
Yes,
let me just kind of write it a little bit neater here and tighter. Okay. So what is the outermost function?
The x to the 1/2.
The 1/2. So if you truly understand chain rule, you say, okay, 1/2, keep the inside. The inside is everything in parentheses. Everything in parentheses. So I mean, I've got the ability to just copy and paste here. It's all of that is, let me just slide this up slightly. That's your inside function. Now you have to subtract 1 from this. So that's negative 1/2. You follow that? That we just dealt. So now we've got, this is our inside function, is another 1/2. So what's the derivative of the, well, I'm sorry. Our next inside function is this x plus x to the 1/2. So we're looking at, let me put this off to the side. let me say this is our next inside function. You have to take the derivative of this. Derivative of this is x is 1 plus what's the derivative of this thing? Well, you got to start with the outside function. So it's 1/2, keep the inside, subtract 1. Okay, but now you have a chain rule. Now you have to take the derivative of this inside function. What's the derivative of this inside function here? This x plus x to the 1/2.
Be 1/2 or 1, my math.
Yep.
1 plus 1/2. Yeah, x to the negative 1/2.
Good. Okay. Maybe that wasn't as clear as I was hoping. Let me try 36 here with you. I think this will be, we'll maybe do the best job of solidifying this. These are really tough, by the way. Like, you're not getting the equivalent that you would see in like a first semester calculus class. These are kind of like the honors calculus type questions. These are hard. So that's what you're dealing with here. The outermost function here is sine. So the derivative is cosine, right? And you keep the inside. This is what you mentioned to me earlier. You basically say, okay, I'm done with this. Now I look at the next one. So now you look at that second sine. What's the derivative of the second sine?
Cosine as well.
Still cosine, right? Doesn't matter what it is. Keep the inside. Now you're done with that one.
Mhm.
And now what's the derivative of sine?
Cosine.
Cosine. Now, the difference between this problem and the previous problem is that you were looking at the left side, which seems to be easier for our eyes than the right side. See how the right side tells you where the outside function is?
Yes, sir.
And that can maybe throw you off a little bit. So just
Mhm.
keep that in mind here. We should do a symbolic one. Oh, these are so horrid. We'll do 39.
I have some more that I can give you that would probably.
It's up to you. This is your time. I want to do whatever you want to help you get help here. Totally up to you. We can move on to implicit derivatives. You tell me what you'd like to work on.
I got a couple problems that I can say, or like give an example or tell you.
Sure. It's if there's any way for you to send it by email, that's preferred, but I'll try it. You just have to confirm that's written correctly.
Okay. One of them, okay, y equals the square root to the third root, or however it's cube root.
Cube root.
1 plus 4x is inside of it.
Anything else?
That's it.
Great. So this is like a level 1. All the ones we've been doing are like level 2, 3, 4s. So
yeah, the ones that we've been doing are just the homeworks that he's given us.
okay. So I would encourage you to always rewrite cubes as powers or any roots. So this is 1 plus 4x to the power of 1/3. And as a reminder, there's really a 1 here. That's where the 1 comes from. Okay. So the outermost function is the power. So you bring that power out in front. You subtract 1. You got to be good about subtracting fractions. Just have to be. Now you have to take the derivative of the inside function. The derivative of 1, you always multiply here. The derivative of 1 is
0.
D dx of a constant is always equal to 0. So you can write it if you want. What's the derivative of 4x?
4.
4. You're done. So let me have you try one real quick here. I'll make one just like this. Y equals the 4th root of 3x squared minus 2.
Okay.
Do you have a final answer on that?
I'm writing the last line right now.
Okay.
All right, I got an answer.
All right. So what I wrote is the not simplified answer, which is usually acceptable. I don't
That's
know.
how we usually just keep them like that. That's how
Okay.
usually he says don't simplify them.
Yeah. Okay. You said you had another one or another type for us to look at?
Yes, sir. That was pretty simple. Y equals tangent pi x.
Okay. Again, so this is like level one. These are the basic chain rule types because there's only one outside and one inside function. You don't have like nested functions inside there. What is the derivative of tangent?
See if I remember. I think it's secant
Secant squared.
secant squared.
Yeah, so that page I sent you in the chat,
Oh yeah, I forgot I had that.
you like, I know you probably have a lot to remember, but it's like you got to know these. Like you cannot be successful in this class without knowing them. You can't do them on the fly. You just need to know them. So spend whatever time it takes to figure it out. We're not done with this though, because pi x is the inside function. What is the derivative of pi times x? Remember, x is the variable, pi is a constant.
So I assume it'd just be one, right?
It's the constant. The derivative of
Oh.
constant times x is always the constant, so it's pi.
Oh, yeah, that's true.
All right, so let me give you one here. See if you got that sheet out. Derivative of cotangent 3 pi squared x. Give me the derivative of this one, please.
All right.
Take a minute here if you need to look it up and make sure you get that chain rule down. I'm just going to start writing, and you can look if you'd like on there, but
On this part that you just now wrote?
yes.
Oh.
So if you try to multiply 2 times 3, remember x is the variable, and d dx of a constant times x, it doesn't matter what the constant is. I could go on here. I could say 3 pi squared e to the pi natural log of pi, these times x. This is all the constant. And these are the things that the instructors will do to you to make you crazy, because they imply that you're supposed to do something with this and you're not. X is the variable. So the derivative of x is whatever's in front of x. 3 pi squared.
So it wouldn't be 6 pi?
No, it's just 3 pi squared.
Oh, okay.
But they do this to make, like, to see if you're paying attention, like, oh, it looks like power rule, but it's not, because it's just a constant.
Okay.
Okay, we should move to implicit derivatives if you are okay with that, because they are long and they are good use of time here. Is that okay?
Yeah, it's okay. I'm more comfortable with those than I am with chain rule.
So these have chain rule inside of them. So
Yeah,
we'll do one, and then we'll kind of get into the chain rule stuff. So the difference here is that when you take the derivative of x is the same as always. Like, there's no change there. But when you go to y, you start by treating it like X? Meaning like you just apply the rule, but then you always multiply by dy dx, or what I prefer to write as a y with a tick, a y prime. If you're doing this, it's a little slower, and I know time's working against a lot of these things. So I'll try to explain that as we go, but I just wanted to preface that. X cubed, you treat like you always do. Power rule. What's the derivative of x cubed?
3x.
3x squared.
Squared by, yeah.
Okay. With the next one here, you treat it like it's an x. So what would x cubed be? Well, you just said it. It's 3x squared. So here it's 3y squared. But because it's a y,
That's a y prime do it.
you actually y prime. And I make the tick a little bit sideways. That's why they want you to use dy dx to really differentiate it. This is faster, but it's up to you. Equals 1. What's the derivative of a constant?
The constant.
0. D dx of a
you're
constant is always 0. Yeah. I know there's a lot thrown at you in a short amount of time. So from here,
it's okay. Never keep going. Sorry.
From here, you're going to solve for y prime. This is not calculus anymore. This is the calculus is done. So this is like how good is your ability to manipulate an equation. Basically, this is like a literal equation. You saw these problems in a previous class where it's like, given this equation with all these variables and constants, solve for it. You just got to be able to a literal, not liberal, literal, kind of something else. So you're going to subtract 3x from both sides to get there. So you get 3y squared y prime equals 3x squared. Okay, just move that over. And then you divide both sides by 3y squared. And you get y prime equals x squared over y squared. Okay, so let's do some with chain rule, because that's really where you said, hey, this is Matthew, this is what I'm struggling with. So I'm going to jump right to 8 for that. All right. So we're going to start over here on the left. What is the derivative of cosine?
Negative sine.
So this is negative sine xy, because you keep the inside function. Now, xy is the chain rule part. You got to take the derivative of xy, and xy is a product. Do you see that? It's a product. They're multiplied together. You got to use product rule. So I think you said, I can't remember what you said. Yeah, keep the first, take the derivative of the second. So what's the derivative of y if you treat it as x?
It'd be dy over dx.
Right. It's just
or
1 and then y prime. Yeah, or dy dx. Plus the derivative of the first. What's the derivative of x?
1.
1 times, keep the second, y, equals, what's the derivative of a constant?
0.
And what's the derivative of sine?
Cosine.
Keep the inside function. What's the derivative of y?
Y prime.
Y prime. Okay, now this one's different. It's got 2 y primes, one on either side of the equation. So this is, again, it's like testing your algebra, your college algebra, your pre-calculus. As horrible as this is, you actually have to distribute this sign in here. So it just gets bad. So becomes minus sine xy prime minus sine xy times y equals cosine y prime. And I know that's a lot to write. So the better your algebra is here, and that's why you did all that prerequisite stuff, the faster you can get to the final answer. So notice there's a y prime here and here. That means you need to get them on one side of the equation. Doesn't matter which side, like your choice, but you have to, be confident in it. I'm going to move it to the right because that makes it positive over here. So this gives me minus sine xy times y equals cosine y prime plus sine xy prime. And this is a common thing to do. So now that they're on the same side, you factor out the y prime. You're going to factor out the y prime. And that gives you, it's a lot of writing. Okay, and then you divide. So I'm going to switch sides here. So y prime equals, but this is in the numerator, negative sine xy y over cosine y plus sine xy x. Your instructor does not expect you to like simplify these, but they do expect you to get y prime by itself.
I got a question on one part of it. Can
Of
you go back
course.
to it?
Yeah, and it's okay to interrupt me as we go. Sorry
Right.
for not
So
giving you
that
time to
row, the second row right here, yeah.
this one right here. Yeah.
So when you distributed the negative sign,
Yep.
did you do the negative sign XY with it? Like
Yes.
all of
Yes.
it, distributed it?
Yes. So let me like
Okay.
hide this whole thing. See how it's
Mhm.
down here and it's down here.
Mhm.
And then I'll do a different color here. This stuff is right there, and this stuff is there.
So how did the XY prime stay the same? Distributed it.
Trying to interpret what you said. That like normally we put the xy's out front, but like this is trying to think of the right words here. Like this is oh boy. Could you just try to rephrase your question? I'm sorry. I don't have a I'm not
Like,
sure.
so how you distributed negative sign XY,
Yes.
it made the second part like 1y. See how it made it negative sign XY and then times y?
Yeah. So I mean you could put a 1y here, but it doesn't change. 1y and y are the same.
Yeah, and so why didn't it change the XY prime like it didn't change it at all?
I mean, there's a 1 here, I guess,
Mhm.
because you're multiplying it by 1. These are just like appended onto like normally they're written in the front. Like normally it's like minus xy prime sine xy.
Mhm.
But I was trying to just keep it in order. Like okay, let me. I got to be careful because I like this is here's essentially what we're doing: sine x times a plus b. This is
Mhm.
sine x times a plus sine x times b.
Right.
Because and it's no different. This is no different on the over here, I guess.
Oh, okay. I get it.
Yeah,
there's I see what
two.
you're saying now.
Okay,
I get it.
all right,
I'm good. I'm good. Okay.
okay. I'm gonna do 11 next because it's another chain rule with some stuff in it. All right. Left side here. What's the derivative of tangent?
Oh, it's negative secant.
Secant squared.
Oh,
Secant squared xy, x over y. Now you have to chain rule. This is chain rule. So what's the derivative of the inside? Well, it's a product rule. Ugh, right? So product rule says bottom, the bottom is y, times the derivative of the top.
mhm.
So what is the, I'm going to write it over here. What is the derivative of the top? What's the derivative of x?
1.
1. Minus the top times what is the derivative of the bottom?
Y prime.
Y prime over bottom squared equals what is the derivative of x?
1.
Derivative of y?
Y prime.
Good. You got to have that down. It sounds like you got it. So this looks awful because there's y prime here and there's a y prime here. Yeah, it is. This is really, really bad because it's really messy. First thing I want you to see though is that this y squared, it's dividing, but this is in parentheses too. So really this y squared could be out in front. It could be like 1 over y squared,
Mhm.
which means you can clear the y squared because that's kind of holding this stuff up here. Okay, so let me show that. I'm going to copy and paste because this allows me to do this. You're going to multiply both sides by y squared. And that's going to clear it there. So your left side is still secant squared x over y. Y times 1 is y minus xy prime equals this. And then you are going to distribute here. So it's y squared plus y squared y prime. Is that okay? Is that clear?
Yes, sir.
Okay. Now this secant squared, it's kind of like what we talked about in the last one. Like this whole thing multiplies each of these.
Mhm.
And I'm gonna append the variable. So it's secant squared x over y minus secant squared x over y xy prime. Take a look at this left side, make sure it's clear, because that's what you were hung up on the last
Yes,
problem.
sir, I got it. It makes
Okay, so notice that there's y primes in 2 locations, and the faster you can manipulate these equations to see that. So what I'm seeing here is that we need to get, I'm going to draw arrows. If I can get this thing to click, we're going to move this whole term this way and this term right here this way. Okay,
Mhm.
because we want to keep the y primes. Now I've gone to the right. It doesn't really matter, but I like to keep things
Just
positive.
get them
So
all on one side.
you get them all on one side. Doesn't matter if it's left or right. So minus y squared, because I'm moving it left, equals, and I'm going to add this. So we'll do it this way: secant squared x over y xy prime plus y squared y prime. So I just move that term over here, move the y squared to the left. So since the y primes are on the same side, you factor out y prime. And it's up to you how much of this that you show, because at some point you get tired of writing. Your instructor knows how to do this. They're just looking to see if you get the final answer also. They want to see the work, but they know how messy these are. So they're not gonna, knock you down on points for not showing every step, but you got to show a couple here.
Mhm.
So then, to divide both sides by this. So y prime equals secant squared x over y times y minus y squared all over secant squared x over y times x plus y squared. These are pretty tough. These are really pretty tough.
Yeah. I'm getting it.
Okay.
It's not. I'm not like confused, like totally confused. I'm like
Good.
understanding why everything's happening.
Good. One direction to go from here is to do a y double prime implicit differentiation, or to just go back to chain rule or something else. You tell me where you'd like to go from here.
Can we do both?
We'll try.
Okay.
they
Why
all
double primes are, yeah, they take long.
they all take a little bit longer. So let's do. Ooh,
I was planning on scheduling another appointment tomorrow
okay,
because the exam's on Friday and I want
sure.
to get one
Are
that.
you? I did text the number that was provided. You can always text me if you don't see an appointment open, because I can manually add you or do something else. But I also don't know if you have access to your phone. Did you see a message?
I saw your message.
Okay, great. All right, so this is they're asking for y double prime here. All right, now it looks like, oh, no big deal, right? Well, it kind of is. You're going to see how horribly these are in a moment. All I did is rewrite it because it's power rule.
Mhm.
So 1/2 x minus 1/2 plus 1/2 y minus 1/2 times y prime equals 0. Okay. Now, when you're doing y double prime, you have to stop at this line, and this is where you continue for y double prime. I know normally we solve for y prime, and we will absolutely solve for y prime here, but over here on the right, we're going to take the derivative again of this line. And if this isn't what you saw in class, just at least give me one problem to try and prove to you that you liked it. Okay.
Like
So
this.
okay, so but you have to separate, because if you don't, way too confusing. So derivative of this thing on the left is again power rule. So it's -1/4 x to the -3/2 plus, now this is where it gets like awful. So I prefer to leave that constant out. Okay. 1/2. So this is the thing we're taking the derivative of, and this is product rule.
Mhm.
Do you agree with that?
Yes, sir.
Okay. So we're going to do the derivative of the first one. So the derivative of the first one is -1/2 y to the -3/2 times y prime. And then you keep the second, so it's times y prime.
Uh-huh.
Look that over, make sure that was okay.
Yes, sir.
Okay.
I understand that.
Plus, keep the first, y to the -1/2. And then take the derivative of the second, that's y double prime
Mhm.
equals 0. Okay, so the issue is that like you need to solve for y double prime and you need to substitute it for y prime in this awful thing. So we have to solve for y prime over here on the left first, and then we'll come over here and deal with this on the right. So this first one, I'm going to multiply everything by 2. Let me actually do that down here in another line, because you might look at this later. Wonder why I did that there in the beginning. All right, I'm just going to clear this out here. You don't have to show times 2, but it's x to the -1/2 plus y to the -1/2, y prime equals 0. So I move this over and I divide. So you get y prime equals -x to the -1/2 over y to the -1/2. Now, because these are both negative exponents, you can flip it. And this is important because it's so messy. It's y to the 1/2 over x to the 1/2, and then you can put the negative anywhere you want. Is that okay?
Yes.
All right. So we're going to use that wherever we see this. Furthermore, you could even do this. You could even do like a y over x to the 1/2 like that. Like that's because you can distribute that in. Up to you. All right. Now over here, we need to get to this y double prime. So again, this guy let me move this up. Get that right there, and then move that up here. Okay, so like the first thing I'm seeing is let's just clear some of this stuff out. Multiply everything by 4 here, so, or net, yeah, 4 will be good. So we get -x to the -3/2 plus 2 -1/2 y to the 3/2, and then this is y prime squared. Y prime times y prime is y prime squared, which is a little weird, but that's what it is. You've never seen it before, equals 0. So we're trying to get to that. So we're going to move that to the other side, divide by 2. So you have -1/2 y to the 3/2, just all this inside stuff, y prime squared plus y to the -1/2 y double prime equals 1/2 x to the -3/2, because I add this to the other side and divide by 2. And then really it's not bad because you end up just moving this and dividing by that. So y double prime equals 1/2 x to the -3/2 plus 1/2 y to the 3/2 y prime squared, just moving that term over, divided by y to the -1/2. And that's why if you needed this over here, because this tells you what to put in for y prime.
Mhm.
So you know there's a lot to rewrite, and you generally don't need to simplify these things, but this one does kind of work out nice when you do. X to the -3/2 plus 1/2 y to the 3/2, and then y prime, as you can see here, your y prime is this minus y over x to the 1/2 squared. You see how that squared cancels with that, and that cancels with that, so it kind of works out nice. Over y to the -1/2, and then you're done.
All right.
All right, well, that does take us to the end of our lesson. Lessons are actually 50 minutes.
Mhm.
I'd be happy to answer another question for you, or just talk about anything. I'm curious, are you a referral from someone?
Yes, my dad knows someone that knows you, I think.
Okay,
Yeah.
okay. So if you need an appointment and you don't see something available, please text me. I will add something or work with you to get something on the schedule. I modify based on, when people schedule. So I don't want you to not get the help you need. So just let me know.
It says there's one for 6 p.m. tomorrow,
Yes,
so I'll just schedule that one.
great. So
Yeah,
I
that's
send you the
good.
notes and the screen recording out after the lesson. Sometimes it takes me a few hours because I have to finish up my lessons, and then there's a download thing. I upload them to YouTube, but it's a private link, so it's only you that has access to it. And that's really it. I hope you got something out of today's lesson, and I appreciate the opportunity to help you.
Yeah, I appreciate it. That really helped. You really helped a lot.
Awesome. That's it for today. I'll send you that stuff out shortly. Thanks a lot.
Alrighty, cool. Thank you.
You're welcome. Bye now.